Good morning, good afternoon, good hello, hi. It's before 9 a.m. my time. I'm not usually even talking at this time of the day. I have a coffee. And we're going to get into some budget tracker. So as promised, I haven't touched anything since I ended the first stream yesterday. So the plan for today is to have a look and see what Claude did in terms of the specs. We'll have a read through them, make sure we're happy with them, and if we are, then we will create the implementation plan. And we'll probably get started with that first, just because Claude can do its thing in the background, and then I'll probably have a look, because we haven't really looked at the web app setup here at all yet. We've got the specifications we created. Let me just get this on screen. We've got the specifications that we created yesterday. Well, that Claude created for us after the conversation that we had. So if you weren't in yesterday's session, where am I here? So here's the output. Obviously, we've lost the top of it now, but we had a long discussion with Claude, basically going through the project. So the project was, let me just pull this up here. The project was a budget tracker that helps you manage a sinking fund so you're never left short again. The idea basically is we all know that we've got expenses that are going to come up either regularly or irregularly, but I know that I'm going to have to pay like a, oh, by the way, let me know in the comments if the music's too loud. I was told yesterday that even after I fixed the audio issues, that the music was still louder than my voice. So I might just turn it down a little more. Hopefully you can hear the music. Hopefully you can definitely hear me. So yeah, we were building a budget tracker app that would take into account like your pay cycle, whether you get a regular pay or irregular pay, like maybe you're a gig worker or you run your own business. And then on the other side of it, we've got our expenses and obligations. I know that I'm going to have to pay X dollars per month for my internet, for example. But when it comes to like car repairs, I know it's going to be around about this amount plus or minus maybe 10%, and that'll happen every year. So how do we manage these things? How do we make sure that we never come up to the point where a bill that we kind of knew that was coming arrives and we don't have the money in the bank because we forgot to plan for it? So what a lot of people do is they have a sinking fund. A sinking fund is where you sink your money into regularly over time to kind of average out the cost of expected future expenses. So if my car repair is going to cost $600 on average a year, I can put $50 a month in, and then by the time that bill comes up, I'm going to have most, if not all, of the money that I need for car repairs or for like maintenance and service and those kind of things. So we went through and we basically had a conversation with Claude yesterday, and Claude asked us a whole lot of great questions that kind of delved into more of the, not so much the implementation, but the detail aspects of the specifications. And we set it to go, excuse me, and it came up with these 10 specification groups. And we asked it to, because of the starter template that I'm using, when we built these out. Here we go. Writing specs, we create one markdown per file. A good spec covers various things like user-facing behaviors, data model changes. We want to make sure that each one of them says it here somewhere. So yeah, it's the what and not the how. And yeah, essentially we're breaking it down. So we've got an overview of what the feature does, the behaviors that we expect, the data model that we might be thinking about, edge cases, but also acceptance criteria. This is very important to put in our specifications. If we write a specification saying, I want this, and then we get an LLM to start coding, it doesn't know when it succeeded. It will make a best guess, and it'll probably get to 70, 80% right. But if we put acceptance criteria in, then we're setting it up for success a lot earlier. So with that all said and done, I'm just going to make sure I keep an eye on any chats over here. With that all said and done, let's have a quick look at the specs that I came up with. So I did ask it to create charts, and rather than doing ASCII art, I asked it to use mermaid graphs, which an LLM is going to be able to understand a lot more easily. It also means we can do things like copy and paste them into a mermaid graphing tool, and then we can have a look at what that actually looks like. So we've got a landing page here. If they have an account, they can log in. One thing I noticed in here is there's no password reset. So we can log in, enter email, password, or we can sign up, enter email, password. There's also no email validation in here. So this is one of the things that didn't really get teased out during the specification session yesterday, but it's something that we can do today. So in fact, once we're happy with these specifications and we start the implementation plan, once that implementation plan is made, we can carry on editing the specifications and have Claude build based on the implementation plan, because the implementation plan won't change until we rebuild it. So what I'm going to do this morning is check the specs, build the implementation plan, and then get Claude coding against that implementation plan. Then we'll have a look at like Docker and Tailscale and a few other things that I use in most of my everyday coding environments, why and how. And then if we've got time, we might go back and revisit the specs, or maybe I'll do that in the third session. I don't want to keep this morning's too long, mostly because I also need to like take the dog for a walk, and I've got a day job and all of those kind of things. But we'll see how far we get. Let me just double check something over here. Oops, not that one. Just want to make sure. Yeah, okay. Just checking streams are going well and all of those kind of things. This is my second stream in more than 2 years, so trying to remind myself of all the processes that I used to follow to make sure I'm on top of things. I did just lose the chat panel though, so that's a little annoying. Where did it go? Let me just do this, and it's not that one. It's not that one. Okay, this is going well. Chat. There we go. Okay, I'm all set. Thank you for that that interlude. Where was I? Right, let's have a look at the specs. So author user management, we already looked at this and we saw that there's no password reset, but we want a user to be able to sign up, log in, log out. Reset password via email. Interestingly, it didn't put that into the flow, but it looks like it's going to be able to develop that. Session persists across browser refreshes. All data endpoints require authentication, and all queries are scoped to the authenticated user's data. Nice. We're going to have a user with these bits of information, default currency symbol. That was one of the things we talked about yesterday. We're not going to have multi-currency. It'll just be a number, but you'll be able to choose what symbol you would like to see associated with that number. Typically, email on sign-up says already registered. User can create an account, log in, log out, reset. Unauthenticated requests are redirected. All data is scoped to user. Passwords are securely hashed. Perfect. I'm happy with that. What I'm looking at here is basically things that stand out to me as being wrong. I'm not really looking for gaps at the moment, more like if something blatantly shouldn't be there. It's a lot easier than trying to find the gaps, and it means that we'll be able to get the first round of iterative development going. And most of the time, the things that you notice are missing are when you're doing like the user testing part, which we'll get to once the code's running. Onboarding, first-time user experience after sign-up. Two equally prominent paths, uploading bank statements for AI-powered analysis or manually entering income and expenses. Both paths collect the user's current fund balance and contribution capacity. The goal is to reach a useful dashboard as quickly as possible. So if we have a look at what this one looks like, we have the welcome screen. Then you can upload documents, upload a bank statement. Let's just make that a little bigger. Can I make that bigger? There we go. Upload a bank statement. AI analyzes the statements, review and detect income and expenses, accept, tweak, dismiss each. So that's a user action at that point. I guess the review part is as well. The analysis brings that back. If it's a manual entry, then we income sources from natural language or a form. Again, we want people to be able to do this manually in case they don't want to submit the financial information to an LLM. Enter obligations via natural language or form, and then funding set of questions. How much do you have in your fund at the moment? What can you top it up with today? And what's the maximum you can put in per month to try and get us to the point where your fund is at a minimum, and then you've got the top-ups after that. Basically what I just said. What currency symbol do you want to use? And then takes you to the dashboard. I think that's a nice flow. Welcome screen. I'm just going to skim through this because it's basically what the flow had, but there might be extra bits like with the login, with the password reset. So welcome screen explains the thinking about concept, statement upload path or manual path. Both paths converge. User can skip any step and complete it later. Nice. Onboarding status tracked. User can resume if they leave the partway through. Returning users who have completed onboarding go straight to the dashboard. Great. So we've got like a flag of whether or not it's complete. I'm not going to worry too much about the data model. Typically what will happen is if something comes up during development and Claude realizes there's an extra bit of information it needs to store, it'll just do that. Use cases, user abandons onboarding midway, can resume. User skips statement upload. User skips manual entry. User has no fund yet. User doesn't know max contributions. Okay, some good edge cases there that it's already taking into account. Income sources. We had a one for this as well. This one's a bit bigger. I won't go through all of the flows, but I just want you to see the kind of flow diagrams that are being created. So do we have an income source? Start with there might not be one at all. So you can add your first. We can do natural language input through a form or detected input. So detected is when we were talking yesterday about when the spreadsheets are uploaded or there's information in there. There might become a point at which, say for example, you've uploaded one month's pay cycle, bank statement, and there's not enough information there at the moment to realize there's a monthly ongoing expense. Then you upload the second one, and the system might detect, hey, it looks like you've made two payments for around about the same amount of to the same vendor at around about the same time in 2 different months. It looks like this might be a monthly reoccurring. So the system can detect these things, and it'll create these suggestions, which the user can then accept or reject. You can preview, confirm, save the income source. So I was talking about expenses, but incomes would this be the same kind of principle. List of income sources. We want a little a sparkle button on each entry. So every entry that's in there, whether it's an income source or an expense or an obligation, you could click on the little sparkle button and you can then have a natural language conversation with it saying, hey, this amount has just gone up to this from next month, so it can take those kind of things into account. Although we didn't actually talk in the specifications yesterday about what happens if the amount changes and you give it that advice. It'd be interesting to see how it deals with that, because we'll probably do that as a specification change in the future. In fact, maybe I'll start keeping a list here of things we might want to, future ideas. So what if a fixed monthly amount goes up by 10%? Can we tell the system via the sparkles button? How will it then change the projection mechanism? All right, and I'm putting this in here now. I might even just copy and paste that straight in to Claude when we get to the point of making changes to the specifications. Expense obligations is very similar. We can see here that we've got the obligations, and then we've got the NL input, natural language input, the form detected. So that's very similar kind of flow there. Bank statement import, users upload bank statements in various formats. It did ask us yesterday if we wanted to do PDF because that's really complicated, but then we told it that Opus 4.6 is going to be probably quite good at that, so we're doing PDF from the outset. Parses transactions, deduplicates against previously imported data, stores them for pattern detection. User uploads, drag and drop, and file picker. Nice. PDF parsing uses AI Opus 4.6 to extract the transaction date description amount and any reference IDs from statement layouts. We've also got CSV parsing and OFX parsing, which, if you're not familiar, is a standard financial data export format. There's deduplication strategy. We did ask it to think about, what if I buy 2 coffees on the same day and they're both for the same amount? How does it deal with duplicates in the system that are meant to be there? Raw statement files are deleted immediately. There was a privacy thing. Imported transactions are stored with the information here. Yep. User can view import history and browse imported transactions. Re-uploading the same file shows no new transactions if all match existing records. Nice. Ongoing uploads. Users can upload new statements at any time to keep data current. Perfect. Pattern detection. After a bank statement import, the system analyzes transactions to detect recurring patterns. So we look for regular recurring transactions, same vendor, similar amount, regular intervals. Income patterns, regular credits of similar amounts. Subscription-like charges, the same amount of consistent monthly intervals. Annual or quarterly charges, same vendor at large intervals. Irregular, same vendor, varying amounts, and variable timing. Be fun to try and identify that one. I'm interested to see how it represents these in the system, because that's a trickier one to model from a data perspective. How do you define it? And then also, how do you use that in future projections? Each suggestion displays a vendor description. I'm not too worried about that right now. We will come to that when we're doing the user testing and we actually see it in action. User acceptance. Suggestion feed is accessible via a nav item. Sure. High confidence suggestions may also appear as smart nudge cards on the dashboard. Nice. We didn't really talk about them having to be high confidence, but it's adding extra little features in here, probably because maybe there's like 20 suggestions and we don't want them all on the dashboard. Already tracked income sources and obligations are not resuggested. Makes sense. Sinking fund engine. The core calculation engine, this is the part I'm interested in. Every obligation has its own virtual fund that tracks how much has been notionally set aside for it. That's right. So just to recap from yesterday, we were talking about the idea of having a fund that all the money would go into, and then we would project out the costs that were going to be incurred over time to make sure that as the fund is topped up and those costs come out, the value of that fund never drops below 0. That's the goal, right? You're never left short. And then we thought, well, some people might want to have one fund for their monthly expenses and another fund for their ad hoc, less regular expenses. Some people might want one for all of them. Maybe some people might want one separate for taxes, which is, again, you know the cadence, but you don't necessarily know the amount. All of these kind of things. And my suggestion to Claude was, let's create 3 different funds under the hood. But then I, as a user, can go in and say, well, these 2 funds here, I actually keep them in the same physical bank account, so I want to join them together as they're represented in the application. And Claude then suggested, well, what if you have a fund for every single unit of things? So your Netflix subscription has one fund, and your internet subscription has one fund, and your tax set-asidingness has one fund. And then you can just combine all of those under the hood and have a single account, or you can split them exactly as you want. And the calculations never change. It's just a sum. which I thought was a really clever way of doing it. So we went with that. It calculates adaptive contribution amounts, including ramp-up periods where the user is behind and ramp down when they're ahead. Users see contributions aggregated by fund group, so you can group those funds together. The system is purely informational. It tells users what to set aside, and users self-verify. That's right, we're not going to be connecting two bank accounts to verify any of this information. Dashboard shows users syncing fund health at a glance, what to do next when they're on track, forward timeline projections, upcoming obligations, responsive design, works across desktop and mobile. The 3 complementary AI interaction modes that users discover naturally at different moments are a floating draggable bar for freeform input. So the idea here is having what kind of feels like the live support that you see typically in the bottom right-hand corner of a website. But when you click on it, you can actually drag it around and put it anywhere on the screen, because sometimes it might be covering up something you might want to be looking at. We'll also have per item sparkle buttons for contextual actions. So if there's like an income or an expense that we want to change, we can click on the sparkle button, and then we can type natural language in there to get AI to then help us make those changes. So again, from before, maybe I'll say, as of next month, this amount is going up by 10%, or things like that. I cancelled this effective October. That'll be an interesting one. See whether I can then project that end date. Anyway, users can create, edit, query, and manage income sources and obligations using plain language. Sure. And then we had the what ifs as well as a scenario creator, which I don't actually remember talking to Claude about. It came up with it and then kind of assumed that this was something we were doing. And I'm like, sure, why not include that? Inline scenario exploration integrated directly into the existing dashboard and obligation views. Users can toggle obligations on and off or tweak amounts. That's fun. I don't remember us talking about that, but sure. What happens if I go onto the next plan up or the next plan down? It's a good scenario builder. They can immediately see the impact on the timeline chart, hero card, and health bar. No separate mode or page. Scenarios are overlaid on top of the real data. What if state is session only and lightweight? Cool. I'm happy with these. So what I'm going to do now is let's have a look at the prompt plan. So this is the Ralph process of getting an LLM or an AI assistive coding agent to do the work for you. So you build the specs, and then you do a single iteration over those specs to turn it into an implementation plan. And once we have an implementation plan, we then run the Ralph loop, which iteratively goes over the plan over and over again. And once we start that, which might be today, this session, it will be today. Once we start that, we will before we start that, I'll go through the process. We'll look at that plan, but that prompt. So we'll have a look at the planning prompt first. So the plan mode, your Ralph, an autonomous planning agent. Your job is to read the specs and code base. We do have code base. We've got a default Next.js app here that's got Prisma ORM and we've got Vitest and those kind of things. But that's a bog standard just being created. There's nothing in there of ours for this project. But have a look at the code base. Produce a clear task list in implementation plan. We need to read implementation plan. One doesn't exist at the moment, but next time we run the iteration or the planning mode, it will take the existing plan and then it'll modify that plan so as not to lose context of what's already been done and implemented, but to augment it, or usually just append information to the end based on new specifications. We need to read agents MD, which has the conventions that we use. We can have a look at that in a sec. Read all the files in specs, scan the code base to understand what has been built. So we want to have a look at the file tree and also key files. Step 2 is to determine what changed. Well, currently there's nothing, so everything's new. Compare the specs against the existing plan and code base, and then we want the new specs. That's going to be us this time. Changed, unchanged, or bugs or gaps where the code base doesn't match the spec. These aren't going to apply to us the first time. It will the second time, obviously. Only items in the first 3 categories need new or updated tasks, but do not assume a functionality is missing. Confirm with the code search first. This part here, new or updated tasks, is quite important because we don't want it to redefine the task list from scratch based on what it's seen. We need to keep the task list intact so that the context of the implementation isn't lost. If we change the wording of the implementation plan but mark it as done, then there might be an inference there that something if it was built a different way, again, because it's all non-deterministic, we have to think about the fact that every time we run any of these loops, it's going to think about it slightly differently. So break work into atomic tasks. I touched on this yesterday, and this is the key of the Ralph loop. We're building one small thing at a time. So when we look at the auth system, for example, one small task might be to create the form, and that would be it. We don't hook the form into anything, we're just creating it. The next task might be to hook it into an API backend or whatever. By making it one small task, the Ralph loop, when we start building, will pick up one task, complete that task, and then exit. And then it'll start again with a fresh context, and it'll pick up another task, complete that task, and then finish it. So the idea there is we're keeping the context window during the build phase really small, which means it's able to avoid things like context rot, detection. What are the words I'm looking for? Context rot, drift, and poisoning. There we go. It's got an idea of some bad task ideas. Build the posts feature. Good tasks are create this endpoint, for example. Step 4, write the plan. It's an incremental update, not a rewrite. Modify it. What you must not change. Complete tasks that should never be edited. So anything that's got a tick off already. In progress tasks, never touch the current progress in tasks being actively built. This would be useful if we started a plan process while a build was ongoing. Generally, I don't do that. I haven't tried that. It'd be interesting to see how much chaos we can throw into the system. I probably won't do that for this hackathon. Existing backlog tasks for unchanged specs. Do not rename, reorder, reword, or remove them, leaving exactly as they were, even if you'd phrase them differently. Again, it's important to maintain the same wording to try and keep as close as possible the interpreted implementation of that task similar, so that when future planning processes take place, there's no assumption that something has been done that hasn't been. And when build processes take place, you're not trying to build something that might already been built, or you build something, but you miss out something you thought had been built, if you know what. Yeah. What you can change. You can add new tasks, totally fine. You can add new tasks. Add new tasks for specs, add new tasks for changed specs, placed near the existing task for that spec. So we're now contextualizing that within the task list. Remove backlog tasks, if they haven't been done yet. Whose spec was deleted. Update backlog tasks that no longer match their spec. Move completed backlog tasks to the completed section if the code base shows they're already implemented. This one's important because sometimes, and we'll probably do that during one of these sessions, is I'll do the spec, I'll do the plan, I'll do the build. Then I'll come back after the build's finished, and then I'll work directly with Claude to make specific changes in kind of like a hand-holding interactive style, which means that the code's being updated. And while I will ask Claude to keep the specs updated at the same time, it doesn't always. So it's important to know that something that we might have planned to do in the future might already be done, because I then handheld it through that process. And then promote the next backlog to the task. Move it to in progress if in progress is empty. So here's a bit of a plan structure. Then we commit the plan, we add it to we stage the file, and then we commit it to the local repository. I used to have it give Ralph or Claude the permission, I guess, through the prompts to push to a remote repository as well. I've stopped doing that now, mostly because it wasn't really causing any issues, but I feel conceptually it's just nice to have that manual point of confirming it's ready for the next environment. It also means that in a team environment, if I was working with other people, obviously I'd be working on my own feature branches or bug fix branches, but it just creates less chance of pushing something into a remote repository that other people are also using that would then cause Git tree mess ups and that kind of thing. Every task must have an acceptance line and tests line. It's important. We are going to be building tests. And at some point this week, I'm sure I'll cover my thoughts on whether it's correct or right for an LLM to both write the tests and the code that satisfies the tests. We'll come to that for sure. One task in progress at any time. Move the first backlog item there if it's empty. Keep context usage minimal. Don't read the files you don't need. The plan is incremental. If nothing changed, make no edits and skip the commit. and then stop after committing the plan. Do not implement anything. Some of these things are a little like the plan is not actually going to be doing any of the development. So the whole thing about if there's something in progress, then move the first backlog item if there's nothing in there already. That's more like setting the stage. It's creating it ready for the build process. Even though some of these sound like it might be to do with the build process, it's just setting that first entry point that when we'll come to it later, the build prompt will then refer to the implementation plan, and we're building that implementation plan for the build prompt to then start building. Anyway, I hope that makes sense. I'm going to come down here, and we're going to kick off a Ralph loop in plan mode. So web container is not running, started first. So this is something I've been working on. Would like to access data from other apps. Yes, it would. And that's because, let's just inject my keys into there. That should work. Okay, so what's happening at the moment? We don't necessarily need this for plan. The template that I'm working off is free and open source, and you're welcome to use it. It's this one over here, next to Prisma Ralph template. And this is work in progress for me all the time. Basically, I'm trying to create a baseline application. Doesn't have any knowledge of what you want to do yet, but it has all of the tools and systems in place to give you a really good launching point for writing, in this case, an Next.js application that uses a database. I use Postgres. We're using Prisma ORM. What else do we have in here? We've got Vitest supporting packages. It helps you write the specs and lets Ralph do the planning and building. So there's some changes in this repo that I don't know if I've pushed them in yet. But technically for the plan phase, you don't need the Docker app running. I just want to double check and make sure that Ralph is running or Claude is running. We don't have an implementation plan yet. I'm just going to, first set of specs, let's just commit these. All right, so theoretically, I believe at the moment Ralph is running a background. We'll come back and check to make sure the implementation plan is actually running. Although we can actually ask Claude. I just started Ralph plan in a terminal. Can you check it's running? Running. Does it have any questions for me? No, off it goes. So the way I usually do my coding nowadays, no Ralph process is currently running. The only grep in the command is the grep itself. So what's going on over here? I mean, the containers have started. Let's actually have a look ourselves. Did actually? I think I just ran dev, didn't I? So this is just the dev running. See, I told you. This is how much coffee I've had. Surprised I'm even. I don't know. All right, so the dev container is now running. Now we can run Ralph plan. Inject my keys. Running. So I'll try describing my process again until something interrupts me. So when you're running Ralph in plan mode like this, I'm running it in a container. The main reason why I'm running it in a container is Ralph is running with a flag called dangerously skip permissions. So if you've used Claude code, as you're typing questions, sometimes it'll ask you a question like, can I read this file? Can I create that file? Can I run this terminal command? Can I delete these files? Can I research things on the web? Am I allowed to access this content? All of these things are designed to be guardrails to allow you as a human who's got slightly more nuance around what the effects of that could be, to step in and say, not just yet, let's think about this. Or yes, that's fine, go ahead. When you run with dangerously skip permissions, it's not going to ask you any questions. It's just going to go. It's the YOLO mode. You only live once. That's just whatever I want to do, I'm going to do it from Claude Code perspective. Which is great, because when you run an autonomous loop, you don't want it to stop and ask you questions. We've defined some really good specs. We're about to create an implementation plan. When I get it to implement, it's going to go for an hour, 2 hours, 5 hours, whatever. I don't want to be waiting at my screen to answer questions. So we run it with dangerously skip permissions. Now, the downside to that is that if an LLM decides that the best way of, let's do a little bit of a sidetrack. So I'm not sure whether you've looked into OpenClaw. You've probably heard about it. There was a really fun retelling of an event. I think it was the guy who created OpenClaw who this happened to, but he sent, it was, so he basically started by using, I think it was WhatsApp or some kind of messaging tool to talk to OpenClaw. And then one day, rather than typing, he did a voice message. And then he thought to himself, well, that's ridiculous. I haven't given OpenClaw any tools to analyze audio messages. Meanwhile, at the back end, because OpenClaw is basically designed to be an agent that will not stop at any, will go to any length to complete its task, it receives this message and it goes, well, I'm not sure what to do with that. So it analyzes the file, it downloads it and analyzes the file and says, okay, this is an audio format of this type. So then it had a look into ways that it would be able to analyze this, and the fastest way, not necessarily the cheapest, but the fastest way that it could do it, because it's one of its premises is to do it as quickly as possible, was it scanned the hard drive, found an OpenAI API key, sent the audio to OpenAI, had OpenAI create a transcript from it, then use that transcript to as its prompt. But then it went one step further and said, you know what, because it came in as audio, I'm going to reply as audio, but it didn't have a way of creating audio. So it downloaded Whisper, I think, and also so it created an audio response and sent that back to the user. I don't know why I went off on that tangent. I do that often. LLMs are going to do whatever they can to make something work. So if my prompt suggests that we need, or if my specs suggest I need a certain feature, and the way to get that feature is to upgrade a library on the system that something else that I use day to day relies on, like this could be a system library. Maybe it decides it's going to downgrade my OS, or it's going to reformat my hard drive because it's going to install Linux or whatever. If I'm doing that in a container, I don't care. If the container dies, then I just restart the container. So that's why I'm running these things in containers. So the web application itself, we have 2 Docker files. Got one for the web application itself that we're writing, and then one for Ralph. So Ralph starts in its own container. If it destroys that container, who cares? We just restart it. That container does have a socket connection to the other container, so it can interact with it. And that's how it does things like running tests and these kind of things. But it's contained, and anything that it does can't affect the rest of the system, any of my other projects, all of those kind of things. The other thing I do is I use, do I have a setup in this one? I don't think I have a setup in this one. And maybe, you know what, I might just add it manually. What I do in a lot of my other projects is I set up Tailscale. Now, Tailscale can offer predominantly, it's known for 2 things. One is for creating a private network between systems that could be anywhere in the world. So if I installed Tailscale on this machine and you had it on your machine, and then we also installed it on another machine in a whole other country, and we were all on the same network, then we would have a local IP address to be able to talk to each other. And that's all like TLS encrypted and all of those kind of things. So you've got like a distributed virtual network around the world or the city or even in your house. Some people will install it on their Home Assistant so they can control their home from anywhere in the world, those kind of things. The other thing the Tailscale allows you to do is run a funnel. And a funnel basically exposes your system to a public IP address. It'll give you a host name as well. So you'll have whatever name you want, .ts for Tailscale, and then some 6-character, 8-character hexadecimal string, which is unique to you, .ts.net. And now that host name will point to the system that's running that particular Tailscale instance. So what I'll often do is inside my Docker container, I'll run Tailscale in funnel mode, so that I can then access the web application or whatever I'm running in there. Maybe it's a database or whatever. Probably wouldn't open the database to the world, to be fair. But I can access the web application by that URL, which I'll actually use for local testing. But then it means, I mentioned yesterday, where's my phone gone? I don't know why I need to show you a phone so you know what a phone looks like. Yesterday I talked about Happy, which is an Android and iOS app that connects to your... we have an iteration going here. That's good. Anyway, Happy is an app that runs on your machine as well, and it wraps Claude code. And then from my phone, I can control Claude code. Now, the downside is if I'm on my phone telling Claude code to update the specs and then rebuild, and then I want to test the application, I can't do that because the application is running on my machine, in a container no less. But with the Tailscale funnel, it means that from any machine in the world, this is why I want to do this for this project as well, because maybe as we get it up and running, you'll be able to interact with it while we're actually developing, which would be fun. But anywhere in the world, you can use your Tailscale address to access your development environment. So I have Tailscale running inside the Docker container, and then a separate Docker container for Ralph to run in. So that's why I still hasn't created anything. It's working on it. So this is basically doing a lot of stuff in the background. Opus 4.6 is actually blowing my mind. It came out like February 6th, February 9th or something. It's only the 11th now. So really that recently. Anyway, at some point within the last week, I believe it came out. What is time anymore at the moment? At some point in the last week it came out, and I used an older version of my prompts with Opus 4.6. And it did not include this part here where it says just atomic stuff. One thing, single, each task must be one thing. And then in the build, in fact, we have implement the smallest thing that works. So I had this to a certain extent. This is a lot more thorough and specific because Opus 4.6, I generated the specs and then I ran the Ralph build loop, and it ran for I want to say that was the one that ran for 3 hours the other day. It might not have been. I'll have to see if I can find the logs. It ran for a long time. It was at least half an hour. And at the end of it, I was talking to Claude and I was asking it to look at the logs and analyze what it had done and give me a rating of the process and all those kind of things. And it said, yeah, well, Claude, Ralph finished development. Do you want to run the iteration for a second time in order to verify the work? And I said, hold on a minute, it only did one loop? And it says, yes, it did everything in one loop. Opus 4.6 is getting much better at managing context. It's got, I think it's twice the context window of Opus 4.5. And it's doing things like one-hitting it, one-shotting things is becoming more and more, I hesitate to say reliable. It's happening. The code that came out after that one shot was pretty good. I had to do a couple of tweaks and fixes, which I wasn't surprised about. I would have expected to do that anyway. But yeah, that's why I made this a lot more specific. I want it to keep a small context window, and there's two reasons for that. One, perhaps Opus 4.6 is as good as keeping that context window small and cleared, and all of the things we're learning at the moment about small context windows and clearing those out often helps create better code faster, more reliably, all of those kind of things. Maybe Opus 4.6 is as good as that process. But at the end of the day, the context window is still growing and growing and growing and growing and growing throughout that whole 30-minute, 3-hour, whatever period. And every time there's a new conversation, because even though it's a single loop of Claude running the implementation plan, within that, the Claude code is sending multiple requests to Anthropic servers. And every time it does, it has the whole context window. Now, I'm sure we're probably doing some compaction in that time as well. But instead of that growing and then coming down and then growing, oh, there's the implementation plan, and then growing, and etc. If I can always keep it small, I'm going to be saving tokens. And at the end of the day, token usage is one of the things that I look at optimizing. Yeah, anyway, so now the implementation plan is up, let's have a look at this, because what I would like to do, given the time, and we've been going for I don't know how long, because I still don't know how to use my streaming tools. We'll have a look at this, we'll kick off a build, and then I'm going to go off and walk the dog. And then I'll come back later and we can have a look at how the build went. So completed nothing yet, in progress. So as we saw in the plan prompt, it says take the first thing and put it into progress. The first thing is going to be to add the user model with Prisma migration. It's going to create this file. It's based on the specification. The acceptance is the user model exists in the schema with fields. And then we're going to build a test to make sure that it succeeds. And then the other things we're going to do is add log error to logging. We're going to add password hashing utilities, session management utilities, and see how it's gone really granular on each of these tasks. And we're going to do one of them at a time. And whew, look at this. So all of these, this is basically, that's a lot. It's good though. So based on, I think the stream yesterday went for 2 hours, and if I hadn't been the waffle at the beginning and probably the middle and the end, knowing me, if I had just had the conversation with Claude yesterday without explaining what I was doing and having that like secondary narrative dialogue for the benefit of you all watching, it probably would have taken me maybe half an hour, possibly 45 minutes, probably half an hour to go through that process. And then I could have walked away and it would have built the specs we saw at the start of this stream. So half an hour would have built the specs. Building the specs probably took maybe 10-15 minutes. I don't know. I walked away, but that's typically how long it's taken for some of these things in the past. So I might have gone away, grabbed a coffee, come back, started the... In fact, sometimes what I'll do is I'll just do a Ralph plan, ampersand for like, and then if this doesn't fail, do this on the command line, Ralph plan and Ralph build, and then I'll walk away. So it would build the implementation plan, then it would have gone straight into building. I would come back. It'll be interesting to see how long this one takes. But that half an hour of planning has produced, hopefully correct, but like a huge amount of tasks, very detailed or very finely documented and specified for Ralph build. In fact, I'm probably going to have to do that. Ralph build to start building with. So the first thing I need to do, no, I don't need to do that at all. I was going to say I need to check that the web app's actually running, but this should work as well, even if the web app didn't exist in its default skeleton version. So I'm going to probably needs to .sh. There we go. I'm going to kick this off. Going to inject my keys in again. And I'm just going to make sure that these iterations work. So we've got some logs coming. Let's have a quick look at the logs, make sure things are actually tracking. I don't want to walk away and then come back and find that that nothing's actually happening. So that's running, that's running. I want, let's open another one here. I'm going to put this one up there. So in here we'll run Claude. What's happening in Ralph build? And I'm going to paste in those log files. So it's going to be able to tell me that, because this is all coming out in JSON, which is the standard way that Claude logs things. Whatchamacalling, what? I would have said whatchamacalling it, but anyway, whatever. I often correct Claude's fun words. Ralph is working on the first task as user model, reading this. That looks cut off here. Okay, so it's actually doing something. We can see we're on iteration 1 of 5. So what I'm going to do is, this is an older version of, I need to do a push to this repository. But essentially what's happening is in loop, we have a default iteration of 5. So do I have the stop command in here yet? Okay, maybe in the next session I'll talk a little bit more about how ref and loop work. And in doing that, we'll have a look at the template that I'm using, because I also have a stop command in there now, because that's important, because in build, we have this. No, we don't. Okay, so in the next session, we're going to make improvements to ref and loop. We're going to bring that into the budget tracker. And that's going to allow us to stop after an iteration. At the moment, if I hit Control-C, it's going to stop the current iteration completely. I want it to finish its current iteration, then I want to stop it, and I want to start it with a higher iteration limit. I'm going to set it to like maybe 60. Although, as I mentioned yesterday, that was a bit short. The downside is that if there's nothing else to build, it's going to carry on going. But that's a problem for the next session. So trying to work out whether I leave you here and I just do that when it's ready. It looks like some files have changed. It's always fun to see what's, so you can see here is building the schema. It's got a migration SQL that is built. So you can keep an eye on what it's doing as you go along, which is fun. I would like this iteration to finish now. Coercion apparently doesn't work. Drink some coffee. Well, according to this, I did implement it. Did I miss something? Clear the stop file, and then, oh, so the stop file is cleared here, but then in the loop, we check for the stop file. There's stop file. And then if the stop file exists, it'll exit. So that'll now automatically stop this loop when it's finished. And then what I'm going to do is I'm basically going to run, in fact, I can do this. I can prepare that here. I'm going to run ref build, and I will give it like 200 iterations. At some point, I'll come back and I'll make sure there's actually still doing stuff. I might stop this process off stream, but I will make sure the build process finishes. And then when I start the next stream, we'll definitely be at the point where there's code built and we can have a look and see how it's working. We'll probably need to do some manual work to get the web application up and running and those kind of things. That's a one-off infrastructure stuff thing, most of which Claude can actually do. But I want to walk through those processes and give you an idea of, like I said in the original description, I'm going to show you the warts and all. We'll show where things go wrong, where things go right, and how the process is working for us. But I'm going to call this a stream for now. I mean, it is a stream, but I'm going to call an end to this stream for now. Like I say, I will stop this iteration. I will start it with like a limit of 200, and I'll see you in the next stream. Keep an eye on, if you're not subscribed and you subscribe and do the ring bell thingy, then you'll be notified when I go live again. I typically post on LinkedIn and Twitter as well, about 5 minutes before I go live. Yeah, hope you're all doing well, and I'll see you in the next one. Ciao.